right, let's go ahead and start by taking a look at the extra credit that you did last night, page 173, number 2. And go ahead and read number 2 there on page 173 for us, if you would, Brecken.
Find two numbers whose difference is 38 and whose sum is 70.
All right, and how did you represent your first equation, Noah? Because it said that two numbers, which we don't know what they are, so we'll call them class X and Y, have a difference of 38. What was your second equation, Maddie? Because it says that the sum of those numbers is 70. For both of you, you had this system, I believe. Pretty straightforward to solve it, Brecken. So that should have been your first number, would have been 54, the number represented X. And then for your second number, which we would have represented Y, we would plug in the 54 to either equation. What did we get for the Y, Noah? 16. Sure enough, the difference is 38, the sum is 70. Those are your two numbers, and both of you had that for the extra credit questions on the extra credit. Clear your desk, except for a clean sheet of paper and a pencil. We're going to go and take that quiz we were supposed to take yesterday in our last lesson, but with these shorter 35-minute lessons lately, it's a little harder to fit everything in the way that we want to, so kind of adjusting on the fly simply by moving that quiz to today. We will get back into more word problems once we're done with the quiz, but for now, sheet of paper, pencil, everything else away. First and last name at the top of your paper, along with today's date, which is 4/8/21. 4/8/21, today's date. Very straightforward quiz. There are 5 systems of equations to solve. You may use whichever method you would like. Be sure to leave your answer as a pair of coordinates. Also be sure to show all of your work so that if you happen to get the wrong answer to one of these, I can find a mistake easily and give you partial credit. All right, you may begin. Use that quiz copy as a cover sheet. Again, this is quiz 30. a couple more minutes remaining to be finishing up. Students in here are finished, so we're going to go ahead and move forward. However, if you need to pause the video for just a little bit, you may certainly do so. All right, we'll take a look at those tomorrow. Let's go ahead and take out your textbooks. Turn to page 173. Page 173. Let's take a look at some word problems here together. Page 173. And I want you to go ahead and work number 1, very similar to the extra credit we had last night. Take just a couple minutes to do number 1 on your own. I promise we'll get to more interesting word problems soon. Just get the practice of setting up a very straightforward word problem. And what was your first equation, Brecken? That's a y, it just didn't look like a y. X plus y equals 48. Good, the sum of two numbers is 48. Your second equation? Great job, x negative y equals 14. And I assume you had the same equations? Assume we canceled the positive negative y to get 2x is equal to 62. Should have gotten our first number, Brecken, to be 31. You plugged that back in and got your second number, anyone, to be 17. Did we get 31 and 17? Good, let's move on to something just a little bit more interesting. Number 3, read that for us if you would, Maddie. All right, the first equation, really straightforward. At your seats, write it down. And Noah, tell us what you wrote. Good, x plus y equals 15. Two numbers have a sum of 15, no problem there. The next equation is the interesting one. It says one number is 2/3 of the other number. How do you suppose we would write that, Maddie? Perfect. Remembering that is means equals and of means multiply. One number, I don't know, x, is equals 2/3 of the other number. 2/3 y. How many thinking the same thing Maddie said? All right, does it make sense now if not? Ooh, thoughts on how we would solve this? Noah, let me bounce back to you here. Okay, we could solve by substitution, we could take the 2/3 y and plug that right here for x so that it becomes 2/3 y plus y equals 15. I think that's a good move. What might we do next? Noah, the rest of us working along with Noah. Okay, and what is 2/3 y plus 1y? Good, 1 and 2/3 y is equal to 15. Now, right there though, it's like, ugh. So thoughts? I hate mixed numbers. Period, full mixed numbers in algebra are just awful. Now let's turn into the improper fraction 5/3 y is equal to 15. And I can get rid of that 5/3 in one quick, easy step. And we haven't done this in quite some time. Somebody help? Essentially what we do is divide away the 5/3, right? But do we ever really divide fractions, class? No, so way back toward the beginning of the year, I said if you've got a single fraction variable, to get rid of the fraction, multiply by the reciprocal. We could multiply by 3/5, and that knocks out both the 3 and the 5. Just make sure you put the 15, class, over 1. There we go. So the 15 and 5 can cancel, and it'll give us y is equal, class, to 9. And there's our answer for y. Now we're not done because again we need both numbers, right? What would I do next, Brecken? In which equation? The top. I hate fractions. Plug it into the top. And so the question becomes, what plus 9 equals 15? And of course the answer would be 6. All right, so we end up getting x is equal to 6. So there's our answer, 6, 9. And sure enough, 6 is 2/3 of 9. Another way we could have solved this is to knock out the fraction right from the get-go. To multiply both sides by a 3 to get 3x is equal to 2y. Now the problem there is it doesn't lend itself to a substitution. But what we could do then is to bring the 2y over and get 3x minus 2y equals 0. The upside of this is I don't have to worry about fractions. So if as Noah was working, and he wasn't scared by the fractions, but if Noah was working like, oh my goodness, I don't want to mess with that, this would have been an option for you. Keep the x plus y equals 15, but maybe distribute a 2 all the way through to get 2x plus 2y equals 30. And now there's our 5x equals 30, x equals 6, plug the 6 in here to get the 9 for the y. Another thing would have been to go ahead and roll with what Noah said initially, plug the 2/3 y in there because it's super easy to do, but maybe here, multiply everything by the LCD. That would have given us a 2y plus 3y equals 45, and of course you can see that gives us 5y equals 45, y equals 9. So there's all kinds of things we could do to avoid the fraction. We could either avoid it right from the get-go, or maybe roll with the substitution, then dispose of it, or like Noah, just roll with it and work our way down through working with the fraction. So a few different approaches to number 3, but the main thing is, can you set up the system? Because if you blow the system, you have no chance on the right answer, right? So on the word problem, that's always key. Get the correct system set up. Questions on this one? Well, let's look at number 7, and a little bit of geometry merging here into our algebra discussion. Brecken, if you'll read this for us.
2 complementary angles have a difference of 36 degrees. Common measure of each angle. Complementary angles are angles that add up to 90 degrees.
All right, so a little bit of refresher from your junior high days. Y'all remember talking about complementary angles? They add up to 90, make a right angle. Okay, and so we've got 2 unknowns. We have our first angle and we have our second angle. And anytime there's 2 unknowns, Brecken, we should represent them, x and y. And right up front, it tells us that these 2 complementary angles have a difference of 36 degrees. Good. And then it just kind of stops there. If it weren't for the parentheses giving us a little clue. The word complementary tells us something. And Brecken, you said complementary means these 2 angles. So that one word complementary is actually an entire equation. questions on that? Does that make sense? All right, at your seats, solve. And check your answers as you finish. Good to go, good. Again, the hard part here was getting the system. I say hard, no, that's super hard, but getting the system. Questions on that one? Number 9, read it for us, Noah.
Two angles are supplementary. When the smaller is increased by 30 degrees, it becomes 20 degrees less than its new supplement. Find the original angle.
Now, this is a loaded one. That very first sentence is an equation because complementary angles, Noah, add up to 90 degrees. Do you remember anything about supplementary angles? Anyone else happen to remember supplementary angles from last year or the year before or the year before? They add up to 180 degrees. Remember, 180 degrees is a straight angle. So the supplementary angles add up to that straight angle. So when it says the two angles, which will represent Noah, x and y, if they are supplementary, my first equation should simply be good, x plus y equals 180 degrees. We don't necessarily have to write the degree symbol, as long as, like here in our answer, we don't forget to put the degree symbol in there. Now the next part is where it starts to get a little stranger. It says if the smaller is increased by 30. Well, the problem is I don't know which one's smaller, right, Noah? So let's just designate one. Let's call one of our angles a smaller angle and one of the angles the larger angle. Which one do you want to be smaller, x or y? X. All right, so if the smaller is going to be x, obviously that means the larger angle is going to be y. So when it says when the smaller is increased by 30, how would I show the smaller being increased by 30? So when the smaller is increased by 30, comma, it becomes, there's our verb class, there's our equal sign, 20 degrees less than its new supplement. Its new supplement. So x and y are supplementary, correct? Whatever those numbers happen to be. Would x plus 30 be supplementary to y? No, x is supplementary to y. Here's a question for you. Let's just make up a random, nice, easy number, though, Maddie, for an angle. Oh, okay, 2 degrees. All right, now remember, supplementary angles, I'm just going to write SUPP for sub. Supplementary angles add up to 180, right, Maddie? So if 2 degrees is one angle, how big is the other? 178, right? That would add up to 180 degrees. So Maddie, if I were to bump this up by 30 to get a 32 degree angle, this is why I was hoping you could do like 10, 20, 30, 40, something like that. But it's okay, we're gonna roll with it. If I were to bump this up by 30 to get 32, what would be supplementary to 32? Anybody? 148 would add up to 180. If this one goes up 30, then the supplement has to go down 30 so that they stay equal to 180. Does that make sense? So since I've raised the smaller angle by 30, the supplement class was y, but now the supplement's going to be y minus 30. But it doesn't say that the smaller angle increased by 30 equals its new supplement, but rather the increased angle increased by 30 becomes 20 degrees less than its new supplement. Does that make sense? So to show 20 degrees less than that, I would need to put negative 20. And there's our system. Yeah. Thoughts on what we should do now, Noah?
Combine.
Yep. Let's combine some stuff here, and what do we get?
Y negative 50.
Right, let's change this to go y negative 50 right here. I'm going to be lazy and just erase it. And then, still looks kind of weird.
Bring the negative 50. Wait.
Help? Anyone?
Or double swap.
I would double swap here. Good. I would bring the y over so it lines up with the other y, and go ahead and send the 30 over as a negative. So what does my lower equation become now, Noah?
X negative y equals negative 20.
Ooh, when this negative 30 moves over, it becomes a negative 30, right? So that actually should give us negative 80. Our top equation will remain for now, x plus y equals 180. Questions on the algebra that Noah had us doing? All right, Maddie, take over. Okay. And so apparently x is 50 degrees. All right, so originally my smaller angle class was 50 degrees, and the larger angle was the supplement. So class, what was the larger angle? 130 degrees. Let's see if that checks out. Because we didn't stay with these angles. Remember, we messed around with it, correct? And when we messed with it, the smaller angle grew to become... Look back at the word problem. What did we do to the smaller angle? We increased it by 30. So the smaller angle grew to 80 degrees. Well, if that's the case, what's the new supplement of 80? 100, right? Is the increased angle now 20 less than its new supplement? It checks out, and there are our answers. Can you imagine trying to work this without a system of equations? It would have been a nightmare. But with a system of equations, although there was some challenge to it, much more manageable, being able to use just easy x's and y's as opposed to something in terms of x and then mess with this and then that also gets messed with and mess again. It's just much easier in a system of equations. Let's look at number 15 now. And this is similar to one of the examples we looked at yesterday. And Maddie, read this for us, please. All right, Maddie, we're going to need to set up a little chart here, and I'm going to need some columns. What columns will I need? Good. P times R equals I. We'll cut out the T because it mentions annual interest. And we've got two different investments. It describes the investments as being a 10% and a 14%. And that immediately tells me I know my rates. How should I represent them? All right, now what I don't know is how much was invested. In fact, that's what it asks. How much is invested at each rate? How should it represent the amounts of investment or the principal? X and Y. And that's going to make our life easier here. How then should I represent the interest earned on each of these investments, Maddie? Good. Now there are two numbers we haven't used yet. Normally we say, what's the one number we haven't used yet? But here there's going to be two because we need two equations because we're setting up a system. The two numbers we haven't used yet, Brecken, are the 5,000 and the 620. What is the 5,000?
Total of the two investments.
So would that be principal rate or interest? All right, what about the 620? What would the 620 be? Oh, wait, they can't both be interest. You can't have an interest of 5,000 and an interest of 620 at the same time. So which one's which net here? Which one's actually the interest? The 620, right? That's the interest. So that means the $5,000 must be the principal. It's the amount that was actually invested. So the 5,000 is the principal. The total principal, by the way, and this is the total interest, What would my two equations be here, Brendan?
X plus y plus
Total means add, right? So x
plus y equals 5,000.
total investment 5,000. Some of it here, some of it there, total 5,000. The other equation,
0.10x plus 0.14y equals 620.
there we go. Total interest. Some of this interest, some of this interest, total adds up to 620. I really hate the decimals though, Noah. Let's go ahead and knock the decimals out by moving it 2 places everywhere to get.
10x plus 14y equals 62,000.
All right. And while we're at it, let's also multiply the top by
10.
yes. I was like, he's either going to say 10 or 14. Please say 10. 10x, 10y, 50,000. All right. And but Maddie, the x's aren't going to cancel despite Noah's efforts because they don't have different signs. We should. And that gives us what? All right. And so we can do that math probably in our head. Class, we get y is 3,000. So that means $3,000, class, was invested at 14%. Remember, how much total invested? 5,000. So if 3,000 was at 14%, then 2,000 was invested at 10%. And there are our answers. Questions on how to use the system to work investment problems. The key is to recognize, like I worked with Brecken, which one of these numbers is principal, which one of these numbers is interest. Now, strategy tip. You'll always invest more than you make. You don't ever invest $200 and make like $600 profit. It does, well, normally. That's not how it works, right? You put a lot of money in, and hopefully you make that money back with interest. Well, they make the 5,000 back with the interest, so the small number generally would be your interest number. Homework for this evening is to do page 175. Page 175. I need you to do numbers 19 through 29, the odd. Page 175, do numbers 19 through 29, the odd. And on page 173, do word problems 5 and 8. Page 173, do word problems 5 and 8. I do have one extra credit opportunity for you, and that is page 175, word problem 33. Page 175, word problem 33. Now listen, this extra credit is not one we've done yet. But like the interest problem, it uses a chart. See if you can figure out how to use a system in the chart to make it happen. One more thing to jot down. We do have a test coming up on Tuesday over Chapter 5. That's Lesson 151, Gavin. Lesson 151 will be your next test, and that test will cover Chapter 5, all things systems of equations. All right, once you have that copied down, you are dismissed. Have a wonderful rest of your day.